The time of the day. On behalf of our group of authors, I present our work, Students' Academic Achievement Assessment in Higher Education Institutions. We can agree that this topic, our concern, students' academic achievement assessment in higher education institutions, is one of the most urgent tasks that teachers face in the role of organizers of the educational process. Theoretical and practical issues of the assessment system organization for academic students' achievements in higher education institutions are covered in the works of Bocharnikova, Kukharenko, Lytvynova, Tomilov, Vasilyev, Kharkov, Ognevchuk, Starichenko, and other researchers. Our article proposes a method for assessing the academic achievements of future bachelors in computer science, for example, the design of practical tasks of the discipline Algorithmization and Programming of the specialty computer sciences. This method is the basis for the control and assessment unit of the module of professional competence formation for future bachelors of computer science. This programming students' knowledge level assessment is carried out using Bloom's taxonomy, which contains 6 levels of difficulty. Each practical task will correspond to its level with a certain number of points, and the levels are as follows: evaluation, synthesis, analysis, application, understanding, and knowledge. Tasks formation is carried out in accordance with the spheres of cognitive, emotional, and motor goals. Cognitive goals cover everything related to knowledge acquisition and mental skills development. Emotional goals include all tasks related to values formation, relationships, students' emotional self-control development. Motor goals embrace motor skills development as well as physical endurance. While drawing up practical tasks, particular attention is paid to the field of cognitive goals, which is divided into the following 6 levels. Level 1, remembering the knowledge level, which is lower level. Level 2, understanding, comprehension level. Level 3, implementation, application level. Level 4, analyzing, analysis level. Level 5, assessment, synthesis level. Level 6, creation, evaluation level, and higher level. This slide shows the contents of remembering level, where it is enough to acquaint students with theory and relevant practical examples. The following slide shows the contents of understanding level, where the students have to draw up a block diagram of a simple task algorithm, implement the algorithm in the form of a program code, and apply the acquired knowledge in the program code into specific simple tasks. The following slide shows the contents of implementation level, where the students have to show their achievement of the previous comprehension level, and in addition, solve, execute, and display a program code with advanced level of complexity and functionality of previous level practical tasks. The following slide shows the contents of analyzing level, and the students have to be able to analyze the task, perform decomposition of the task, draw up a general flow chart of the algorithm and subtask flow charts based on decomposition, and implement the algorithm of complex practical tasks in the form of a program code using functions. Next slide shows the contents of assessment level, where students have to demonstrate all their achievement of the previous analyzing level and solve, execute, and display program code with increased levels of complexity and functionality of previous level practical tasks. Next slide shows the contents of creation level, and students have to demonstrate application of the studied material as a tool in solving complex problems of different directions, performing the decomposition of the task, drawing up a general flowchart of the algorithm and a flowchart of tasks, application of the first paradigm of object-oriented approach, encapsulation, and algorithm implementation with the use of functions. Here is the slide which shows the student educational achievements rating system using Bloom's taxonomy levels, and how each level is evaluated by the number of points. Each level of Bloom's taxonomy is subdivided into the following sublevels: practical assignment accomplishment defense, practical assignment accomplishment quality, and the term of delay, the non-meeting of a deadline for the task for practical assignment accomplishment. The score of each sublevel may be reduced or increased. In order to determine the percentage of reduction or increase in the resultant evaluation of each sub-item, a survey was conducted with 76 teachers from 23 regions of Ukraine and the city of Kyiv participating. The following slide shows the results of this survey, and namely practical assignment accomplishment. Our next slide shows practical tasks defense. The following slide shows practical assignment accomplishment, and here we can introduce an example of practical assignments accomplishment assessment, where a practical assignment accomplished by a student. The percentage of each decrease for practical assignment accomplishment component are summarized in our table 1, which follows the next slide. All percentages of decrease for practical assignments accomplishment obtained are summed up. This slide shows table 1, which shows all percentages of decrease for practical assignments accomplishment and obtained, and how they are summed up. As conclusions, we can present that our technique for educational activity results assessment for future bachelors of computer sciences, which combines Bloom's taxonomy and the classic student assessment system, is presented in our full work. Bloom taxonomy levels contents are observed. Activity types explanation for their assessment system is given on the example of practical assignment design in the discipline Algorithmization and Programming. And our technique has many advantages. First is that it enables, through the use of Bloom's taxonomy, to determine students' competence already at intermediate stages of studying. While accomplishing a task on a certain level, a student is able to understand his or her knowledge level. One of the disadvantages of the technique happens to be the fact that it requires a rather big amount of time for the teacher to create a methodical support complex. We thank you for your attention.